Function notation. Our objective is to write functions using function notation, as well as evaluate and graph functions. Why learn this? Function notation can be used to indicate the distance traveled by a Japanese bullet train. Let's look at some function examples here. We have f of x, that's your output value. And then that equals 5 times x plus 3. That x value, that's your input. So you input a value in for x, and you come out with an output or a solution. So let's move over to the right. If you input the value of 1, so what is f of 1 equals 5 times 1 plus 3. So your output in this case would be 8. Let's look at evaluating functions. For each function, evaluate f of 0, f of 1/2, and f of -2. Keep in mind that the 0, the 1/2, and this -2, those are your input values. That's what you're going to substitute in for x. So substitute each value for x and evaluate. So let's start with 0. 7 minus 2 times 0 equals 7. So f of 0 is 7. Take a moment and try f of 1/2 and f of -2 for a. Now that you've had a moment to try f of 1/2 and f of -2 for question A, let's try it. We have f of 1/2, so we're going to substitute in 1/2 for x. So 7 minus 2 times 1/2, well, that gives you 6. And then when we use -2 as our input value, we get an output of 11. Well, what happens if you're given a graph? So let's look at the right. Use the graph to find the corresponding y value for each x value. So you don't need to do much in terms of evaluating anything here. You just need to look and see. So where is f of 0? Well, f of 0 is here. So where is your x value equal to 0? And then go up and find your graph. 4. So therefore, f of 0 is 4. Take a moment and try f of 1/2 and f of -2. Now that you've had a chance to try f of 1/2 and f of -2, let's see how close you came. So when we want to use the x value 1/2, and when we go up, we are going to be at 3.5. 1, 2, 3.5. And now -2 will meet at 2. So f of -2 is 2. So that's how you evaluate functions when you're inputting values in for x, and then the answer you get is your output value. Alright, your output is also known as your dependent variable. It depends on what you put in. So your independent variable is the one that you're selecting to stick some value in for. So in this case, you have d of t equals 65t. Your output is your dependent. What you're sticking in is your independent. Alright, so in this case, we're just going to go up 65. So for every 1, we go 65. Alright, let's look at an example. Graphing functions. Graph each function. The diagram shows the maximum recommended heart rate for women by age. So let's graph the points. So we have age 0, the heart rate or beats per minute should be at 209. For age 10, 202, 20, 195, 30, 188, and 40, 181. So when we plot the points, we end up with our maximum recommended heart rates for women. So at 0, it's at 209. At 10, it's 202. And it keeps decreasing. we're not going to connect the points because the values between the given points have not been defined. All right, what that's trying to state, or what that is stating, is that they didn't tell us what it is for age 5. So we can't just stick a line in there. They're very specific values. So when you're given specific values for something, you're not going to have a line connecting them like if you were to have had an equation. So let's look at another one. The maximum recommended heart rate H for men is a function of age A, and can be calculated with this formula. So H times A, or H of A, equals 214 minus 0.8 times A. So our A value is 0. That's our input. This is going to be our dependent variable. So H of A is our dependent. What we substitute in for A and then evaluate. So when we substitute a value in, that's our independent value. So our independent here, so we have 0, and evaluate, and we end up with an output for our dependent as 214. And we'll do that for 20, 40, 60, and 80. So when we graph these points, we're going to connect these ones with a line. We connect the points with a line because the function is defined for 0 is less than or equal to A is less than or equal to 100. So when you're dealing with something where it's actually including those inner values, these were just examples. They weren't the values that were given as in a mapping example where they only gave you 0 goes with 209, 20 goes with 195. It's continuous. And that's our lesson on function notation.